We're in. Okay. So, ions or atoms that lose electrons, that process is called oxidation. Is that new to you or not? Have you learned what this process was yet? You've heard the word oxidation. Did you know you were losing electrons? Okay. In this class, we're typically going to associate this with metals. Okay. In other processes, as you guys take more classes, we'll find out there's other species that'll happen with also. When I say more positive, we're going to find out here a little bit, well, hopefully at the end of the day, that there's actually a couple of different ions that iron forms. It's iron 2 and iron 3. So if iron 2 changes to iron 3, that becomes more positive. Likewise, if something starts off at -2 like oxygen and goes to 0, that is also more positive. Does that make any sense? Oh, let me see. You may or may not have been introduced to the word cation in your life. Okay? The cation is a positive ion. Now, if a species gains electrons, that process is called, anyone know, since you knew what oxidation was? It's kind of hard to learn one without the other, since they go hand in hand. You can't have one without the other. You can't have an oxidation without a reduction. You can't have a reduction without an oxidation. Okay? So, gaining electrons is called reduction. Some of you are having a little trouble with that right now, aren't you? To gain something is called reduction. Why is it called reduction? Acquires a more negative charge. So that iron example that I had used earlier, if we went from iron 3 to iron 2, meaning a +3 to a +2, that's still a reduction because it's more negative, even though it ends up being positive. You guys following? Typically it occurs in nonmetals. And I can't get bend down that low anymore. So, when atoms gain, especially in this class, when we look at them gaining electrons, forming a negative ion, we call those negative ions anions. Again, you may or may not have been introduced to that word before. So we have cations and anions. I like to say those words better than positively charged ion and negatively charged ion. It's a lot faster. You guys agree? Where you guys mess up a little bit now, though, is sometimes you forget which one's which one's positive, which one's negative. So just a little hint, it might work for you, it might not, it doesn't have to, but this little letter there, T, happens to look like a plus sign or positive charge, right? It might help, it might not. You do what you want with it.
Cats are positive and anions.
You know, people have tried to tell me that before, and I don't even know what that means. Cats are positive?
I love cats.
Okay, you guys do what you want. I don't care.
Onions taste gross, so just remember.
Dogs taste gross?
Onions.
Oh, onions.
It looks like we still have onions.
What is this, China?
Okay, moving on. Oh, which brings me to this point, which every year I'm kind of amazed that this happens.
Will somebody announce their presence?
Well, that and the fact that my flask is in there.
Oh.
No longer in a
Yeah,
single piece.
it's not.
Did that seriously break it?
You want to take a look at it?
All right, moving on. We sometimes run into a problem now because I find that many students aren't sure where to locate these on the periodic table. So, where might one find metals on the periodic table?
On the left.
In the middle. That's one of the places that you can find them. Yes?
On the left except for hydrogen.
On the left, except for hydrogen. So Matt says these. So on the left.
The left side.
Right,
The
left side,
Left
except
half.
for hydrogen.
The left
The
half.
left half. So
I don't
here.
know.
To the left of the stair step.
Angel?
The stuff to the left of that little staircase right there.
Oh! You mean
Yeah.
to the left of that?
Mhm.
All of them, except hydrogen. All of them, except hydrogen. Yeah. Who? You see where my golf club is?
I'm just asking.
I know. Do you see where my golf club is? Go left. And does that include those elements?
Yes.
Right. Because where are these elements on the periodic table? Right there. Shouldn't the periodic table be about over here?
Yeah.
Right. You guys following?
Mhm.
So yeah, so every one of them, other than hydrogen, and actually, hydrogen, I've seen periodic tables where it's located here. I don't know if you guys have seen that before or not. Okay? Because actually it could belong in either place easily. We'll talk more about that why actually later. Alright, now what are the elements, and your first answer is likely wrong, called that are over here?
Nope.
No.
Non-metals?
Non-metals. Now, how many of you were thinking gases? And it's okay if you were, you're not fired. Okay, there's like 8 other people, okay, and they're just embarrassed, okay? Is that what you were thinking? Okay, I get a little frustrated with that because that means at some point in time you guys weren't spending enough time with this. Are there gases over here? Yeah, there's definitely the noble gases, obviously, gases. Turns out, oxygen's a gas.
Wonder why.
And along with fluorine, chlorine, and nitrogen. All gases. I have just identified, and helium. I have identified all of the gases over there. Is anyone having an issue with that?
There's more elements over there.
Okay, Brennan, what state of matter is carbon? Adrian? Adrian says it's a solid. Anyone agree with that?
I don't know, do I?
Anyone disagree? What is it?
Gas?
It is not a gas. It is a solid. It's a solid you can possibly make a solid. Carbon, the element carbon is a solid. Now, as it turns out, Megan, there's like 10 other people that also thought it was a gas in here, okay? Now, why did you think it was a gas?
Because
Carbon? You better not be breathing carbon because you're gonna have some, there's something called black lung disease that you're going to acquire. Oh, carbon what?
dioxide.
Dioxide. So you say that carbon's a solid because carbon dioxide is a gas.
What?
What?
You, or sorry, you say carbon's a gas because carbon dioxide is a gas. Right? What's oxygen?
A gas.
It's a liquid.
What?
But you just said it was a gas.
But if she is saying that carbon is a gas,
Oh, 'cause water.
because carbon dioxide is
Oh.
a gas, then since oxygen
Some water.
since water is a liquid, then oxygen must be a liquid.
Oh.
See where I'm going with that?
Okay.
Okay, now listen, Megan, I'm not just talking to you, I'm talking to the 10 or 12 other people that, and the 50 other people today that have thought the same thing. Carbon is a solid. For whatever reason, not only you, but if you go out and talk to your parents, they're also probably going to say the same thing. I don't know how this has happened. I'm gonna guess it's the media with that whole carbon footprint thing. You guys don't know about that? Okay. The environmental impact of carbon dioxide. They call it your carbon footprint. So I think a lot of people think carbon is a gas because it's in carbon dioxide. But there's carbon monoxide, also a gas. But there's also which is made of primarily carbon. Most of you aren't a gas.
Hopefully.
All right, anyway, moving on. Yes, Freddie? As it turns out, there are 3 allotropes of carbon. Now, I'm not going to make you responsible for the word allotrope, but it's spelled A-L-L-O-T-R-O-P-E-S if you want to know. But an allotropes are different forms of the same substance. So it turns out for carbon, there are 3 forms of carbon. All solids. Some of them more solid than others. For example, the one that Freddie just mentioned is diamond. Diamonds are pure carbon.
Really?
Absolutely. Pure carbon. Does anyone know any of the other forms? Coal. Pure carbon. Coal and diamonds are made from exactly the same stuff. Carbon atoms, and that's it. There's one more. And every one of you is very, very familiar with it. Even within the last minute.
Graphite.
Graphite. Pure carbon. Would you confuse the 3 with each other ever? No, we have graphite that's very soft, very slippery, very brittle. We have carbon that's very, sorry about that, we have coal that's very black, hard, also brittle, and we have diamond, which is shiny. So I think it's clear, colorless, one of the hardest things known to man, if not the hardest thing. Okay? So anyway, guess where I'm going with this is carbon is a solid. So many people like to think of it as a gas because the whole carbon dioxide thing, but it's a solid. Let me see, where else do I want to go? So, what are the solids? Boron, carbon, silicon, phosphorus, sulfur, arsenic, selenium, thorium, iodine, and acetylene. Oh, that just reminded me of something. I forgot to do it the rest of the time. Sulfur is a solid.
Okay.
What's that? Can be. You've seen this.
Yeah.
Oh, where did you see it? Oh, guys, just curious. A lot of people think sulfur is a gas.
Oh, it's also your gas.
No, but, and again, and then this is one of the things we have to fix here.
Sulfur.
Just because carbon is not a gas because it's in carbon dioxide, sulfur is not a liquid because it's in sulfuric acid. Once elements start combining with other things, they change their properties, okay? I'm gonna get some sulfur for you guys.
Isotope is when different atoms are ions gains or I just remember, like, if you get confused, I just say
And as Lucas was saying previously, I'm going to open this up. You guys okay with me opening up the sulfur? What? Really? Okay, that's fine. You guys know how to wash?
Yes.
Yes.
Okay, now listen. This is what I'm going to get from some of you. You guys will do this. Okay? One, your nose isn't huge. The whole purpose of wafting is to scoop some of the molecules towards your nose.
I'm not wafting it.
Sure you will. Go ahead.
I don't want to do.
No, come on. Maybe not.
I wonder why. I think
Okay, when you guys notice about the smell, there is no smell. Sulfur doesn't smell.
it was probably the sulfur going into your nose.
It's solid, like you said, it's a powder. So you might have gotten some little powder particles in your nose. There's no odor to sulfur. So you've heard the phrase, oh, it smells like sulfur. That means you didn't smell anything. Oh, you want something that smells like sulfur. I gotta remember where
He
to put
does
this.
plan this out ahead. He has a skit.
It's a one-man show.
That awkward moment when you lose your sulfur.
Are you in?
Well, move.
Oh.
When the chemical factory no longer existed, things went other places. Nobody was plants. Come on. I had this earlier this year. I had it earlier.
Like honestly, all we do is measure what's class and like
Have fun listening here because you couldn't get any better than that.
he doesn't teach us.
You don't even have to do it. She got so pissed off about grades. She like doesn't put them in.
What are you talking about? Oh yeah. Oh yeah.
I didn't get all that. Did we go over them yesterday? I don't think we did.
Ah!
I took my shirt. It has a different number of
Now, you guys remember the wafting thing, yes?
Yeah.
I'm just not gonna stop.
No, you're gonna smell it.
Yeah, okay.
Oh.
Oh, it's not even doing that.
Oh. Now that is, I'm like, he held it to here. I'm like,
Oh my god.
and now the whole room smells like that.
It's still there. Still there.
You just straight up said,
Oh,
oh,
it's over here. We're good. We're good. Oh my god.
oh no, ew. We're gonna smell like butt all day. Oh god.
Now, Drew, when I hear people make that comment, just like they usually do, my question is, how do you know?
I don't know.
That's disgusting.
Everywhere I know it.
Now, that is what a sulfur-containing compound smells like.
What can you do to it?
Yes. Yeah, no, ammonium sulfide is what that was. Ammonium sulfide. All right, moving on. Yeah.
Okay, so is that lead test kits?
What?
Like lead
Yeah.
test kits?
Keep going. I'm listening.
Test of lead.
I'm trying to listen. I keep hearing all this.
The test kit. Like pour water into like this tube and then you put the solution in it.
All right.
And I did it for like 2 hours. My house.
Have you guys ever heard the phrase arc diagram? Okay, maybe you've seen it, you just didn't know what it was called. Hold on. Now, don't write this down yet. Remember we did the Bohr model of the atom the other day? So we drew a little nucleus, and then we drew the little... No. And we drew the shells to represent the energy levels. You guys remember that, right? Well, as you can imagine, if we're going to get deeper and deeper into the periodic table with bigger and bigger atoms, those pictures are going to get bigger and bigger and bigger, right? But sometimes we need to depict those without taking a lot of space. So, what I like to use, or what we like to call arc diagrams, where each of these arcs represents one of the energy levels. You just have to imagine that it goes all the way around. Okay, you guys cool with that? Right. The reason I'm doing this is each energy level, you may recall, is allowed to have a certain number of electrons maximum. Does anybody remember what those numbers are?
Like 2.
It is 2 for the first one.
8 for the second.
8 for the second. Now here's where it gets interesting. Go ahead, Paul. No, go ahead. You're going to say the second one? Okay.
Isn't it 8 again?
Well, for our purposes in this class, in this chapter, in chapter 7, yes. 8. And the next one, 8. However, when we get to chapter 4, this is going to be or 18. We'll talk about that here in a second. And this one's or 32. Okay? But for this class, this period, or this chapter, this is all you need to know. Okay? Now, you guys have done this before where you drew little electrons in, right? Never, ever, ever do that again. Okay? 1, you wasted your time doing that. 2, I would, and more importantly, I would waste my time counting them. Okay? And I'm not going to do it. So, if we wanted to represent an element, we're going to do it like this. For example, how many electrons does magnesium have? 12.
Okay.
2 would go in the first energy level, 8 would go in the second, the remaining would go in the third.
Bam.
Boom, done. You guys with me on that? That's how we're going to do it. All right. Wherever you are in your notes, what I need you to do is turn to the next page and then rotate your notebook 90 degrees clockwise. 90's a lot. You can always come back and fill that in. Sure, I don't care. Just the next open page that you like to write on. All right. Don't do anything yet until I'm done because I have to make sure I space this out properly. Good now. All right, go ahead and reproduce that as best you can. Use the entire width of your paper, but not the entire depth. Go wide. Go across. Go long. You're going to run out of room there, Matt. I'm just saying. Right?
There's supposed to be a
I'm sorry, what? Oh, thank you, Sherry. I will address that as soon as I possibly can. I know, because I know you're a bus driver. And the next time I see him, I'll just have it all close up.
Oh no, I don't have space.
And tell him what you think. Moving on. Let's look at the elements lithium, sodium, and potassium. And remember, well, you don't remember, so I'm just going to do it. Okay? Lithium has how many electrons? An atom of lithium has 3. 2 go in the first, 1 goes in the second. Sodium, an atom of sodium has how many electrons? 11. 2 in the first, 8 in the second, 1 left over. Potassium, an atom of potassium has how many electrons? 19. 2, 8, 8, 1. Group 2A. Boron has, or sorry about that, beryllium has how many electrons? Someone? 4. 2 in the first, 2 in the second. Magnesium, as we already know, has 12. I'll go ahead and do boron up here. No, let's do aluminum. Aluminum has how many electrons? 13. 2, 8, 3. I'm going to skip group 4A for now. We'll talk about why here in a little bit. Let's look at nitrogen and phosphorus in group 5A. Nitrogen has how many electrons? 7. 2 in the first, 5 in the second. Phosphorus has how many electrons? 2 in the first, 8 in the second, and 5 in the third. Let's look at oxygen. Oxygen has 8 electrons. 2 in the first, 6 in the second. And just for fun, let's look at fluorine, which has 9 electrons. 2 in the first, 7 in the second. Have you guys ever done anything like this before? No. Okay. There's a couple of observations I want us to get out of this. I'll wait till you guys are done. Trying to think of something else that would help me smell.
No, we're good. Unless it's roses, then I'm not smelling.
That's going to stick in your clothes for a while, everybody.
Are you serious?
Oh, yeah.
Thanks.
Hopefully none of you have a taste after school.
I have work.
Literally, going to go change.
What? You're gonna make good?
No, Adrian.
What?
How am I way different than you trying to say it?
We're doing. I said, there goes the Adrian's plan.
If you were to do this and you didn't write anything, you weren't
Yes.
Wait, what day is, what's day?
To what?
Wait.
See, we're labeling our numbers.
Yep.
All right, here we go. Now, can anyone make an observation about the relationship between the group number, which is group A designations, and the number of valence electrons? Go ahead. Kelly.
Well, the last arc is like has a number of electrons as like the number.
The group number,
Yeah.
the Roman numeral, precisely. Oh, by the way, remind me, are you going to be here at school tomorrow? Okay, write down somewhere that I need to play you guys a song.
Oh,
All right, moving on.
crap.
Anyway, so Kelly, let me rephrase what Kelly said a little bit more succinctly, although she was pretty darn close. The group number indicates the number of valence electrons or electrons in the outermost energy level. You guys know what valence electrons were?
Yeah.
Okay. So, the group number, you probably knew this piece, didn't you? That the group number tells you that?
Yes.
Now, there's a couple groups I didn't put up there. How many valence electrons will carbon have? Anyone want to take a stab? Right. How about silicon? Go ahead. Lucas? No, I'm not going to.
6.
Wow.
Also 4. How many valence electrons will neon have? 8. It's in group 8A. How many valence electrons will calcium have? 2, because it's in group 2A. You guys see where we're going with this, right?
Yeah.
How many valence electrons does iron have?
Oh. 8.
That's a good question.
That is a good question, and we can't answer that question based on the information we have, because this technique only works for the representative elements. The group A elements are otherwise known as the representative elements. The representative elements are known as the group A elements. Have I made that clear yet? Group A elements are known as the representative elements. Group A equals representative elements. Group A, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A.
There's no BA?
Oh, because they all say A. Oh.
Or not.
Okay.
Moving on. Does anyone notice a relationship between the period number and the number of energy levels? They're also the same. So, for example, period 2 has 2 energy levels. The valence electrons are in the second energy level. You guys following? So, where are the valence electrons in which energy level in the 5th period elements? Very good, Matt. What was that? 5 energy levels. See where that's going. Now, let's go back to that 2, 8, 18, all that kind of crap. First period. How many electrons in the first energy level? How many electrons in the first energy level? How many electrons in the first energy level? 2. How many elements are in period 1? 2. Hydrogen and helium. How many elements are in the second energy level? Or second period? 8. How many electrons in the second energy level? 8. Now, here's where that 8 or 18 thing comes into play, which we're going to learn next chapter. As you can clearly see, there's 8 elements in the third period, right? However, I told you that there could be 18 electrons in the third energy level. That's because these elements right here also belong to the third period. We will cover that next chapter. Okay? And as it turns out, these elements here belong here. And they're in the 4th period, or 4th energy level. Again, we'll cover that next chapter. All right, moving on. Now, where are the metals? Those are all what types of elements? Non-metals. The rest of these are metals. Metals have a tendency to do what when they form ions? Lose electrons. How many electrons is lithium going to lose? 1. What about sodium? 1. And what about potassium? 1. If each of those elements loses 1 electron, what charge does it acquire? A 1 plus charge. So all the group 1A elements form a 1 plus charge. Likewise, the group 2A elements lose 2 because they're also metals. Therefore, they're going to form a 2 plus charge. Aluminum in group 3A is going to lose 3 electrons, therefore a 3 plus charge. Skipping over to nitrogen and phosphorus, what types of elements are those? Non-metals. What do non-metals have a tendency to do when they form ions? Gain electrons. How many electrons is nitrogen going to gain to complete its octet? 3. And phosphorus is going to gain 3. Therefore, each of these is going to form a 3 negative charge. Oxygen, non-metal, complete its octet, needs 2 electrons. Boom. All the group 6A elements are going to form a -2 or 2 negative. Fluorine is going to gain 1 electron, 1 negative. Where I'm going with this is the representative elements, or the group A elements, you can figure out their charge based on their location on the periodic table. I think you guys have done this before. Maybe not had it explained to you why, but this is why. Okay? I'd like you guys to know why. So, just for fun, what is the charge on the ion sulfur forms? 2 negative. What is the charge on the ion that bromine forms? forms?
That's
What's that? 2 plus.
it actually comes off.
What about gallium? 3. Is gallium a metal or non-metal? So it's going to be 3 plus. You guys following? You guys can do this, right?
Sure.
Which brings us to this. What's the charge on the iron ion?
Good question.
Yeah, we don't know. Okay? And as it turns out, by the way, these are the representative elements. Does anyone know what these elements are called?
The
The transition elements, the transition metals, precisely. Yeah. The transition metals have a tendency to form, most of them have a tendency to form more than one charge. They're all going to be what sign? Positive, because they're all metals. Okay, they're all going to be positive, but they have a tendency to form more than one type of positive charge. Yes? I'm preparing you for that. I'm not even close to being done, Paul. Now, how are we going to know which iron is which? Well, iron forms either a 2 plus charge or a 3 plus charge. Up until about 8 seconds ago, what would you guys have called this ion? Iron. And what would you have called this ion? Iron. Okay, but you can clearly see there's a difference, right? So how are we going to distinguish that with the names? This becomes iron 2, and this one becomes iron 3. So, where I'm going with this is, almost all of the transition metals I'm having you guys learn has more than one charge that they form. And so our names, when we talk about them, we're going to have to include Roman numerals to tell which charge it is. Does that make any sense? There are 3 exceptions to that rule. They are as follows. Silver, zinc, and scandium only form one ion each. So you just have to memorize what that is. These do not get, their names don't get Roman numerals because they only form one ion. You just happen to have to know what that charge is. Silver is always a 1 plus ion, zinc's always a 2 plus, scandium's always a 3 plus. But wait, there's more. If there's exceptions to the transition metal rule, then there's probably an exception to the representative element. And there are 2, which we'll cover tomorrow. Have a good weekend.
You get this smartboard. Get to know the atomic number for tomorrow's test.
No, absolutely. Just name, symbol. Name and symbol. We're going to talk more about that tomorrow.
Is it just going to be like,
So it's going to be exactly the same as tomorrow,
okay,
except the difference is you have to provide a charge, and if it's a transition metal, you may have to include your own.
Probably.